Blaise Pascal was a 17th century inventor, mathematician, physicist, and religious philosopher. One of the things he is known for is his study and discovery of one of math's most famous triangles, now known as Pascal's triangle. Let's work together to build Pascal's triangle. Imagine that you start at the top of this grid. You are only allowed to move down or right. Each intersection is labeled with a letter. Tell how many different ways you can move to each intersection only moving down or right. Write the number of ways beside each stoplight. When you hear the sound, pause the video and discuss the question I asked with your classmates. If you begin at the star and you can only move down or right, how many ways can you travel to intersection A? There's only one way to travel to intersection A. You can only travel down. You could travel right to B, then down to E, but you would not be able to travel back to A since you can only travel down or right. How many ways to travel to intersection B? There is only one way to travel to intersection B as well. You can only travel right because if you went down, you would not be able to go up again. Now think about C and D. If you can only travel down or right, how many ways are there to get to intersections C and D? Yes, just like A, you can only go down to get to C and right to get to D. You might think this triangle is not very interesting at all right now, but this is probably the most famous triangle in the math world. So what about intersection E? How many different ways are there to get to intersection E? Finally, we find something a little more interesting. There are two ways to make it to intersection E. You can go down and right, or you can go right and down. Now, let's think about intersections F, G, H, and I. How many ways to get to each of these intersections? What did you find out about F and G? Did you notice a pattern? Yes, I'm sure many of you are beginning to see the pattern. There's only one way to F or G. What about H? There are three ways to H. You could have gone down to C and right to H. You could go down to A, right to E, and down to H. Or you could go right to B and down to H. And what about I? There were also three ways. You could go right to D and down to I. You could go right to B, down to E, and right to I. Or you could go down to A and right to I. Now think about intersections J, K, L, M, and N. You might begin to notice some patterns that will help you with your conjectures. Did you say there was one way to intersections J and K? I bet you're beginning to use a pattern for that. But what about intersections L, M, and N? Let's look at intersection L first. There are four ways to intersection L. You can go down to F, right to L. You can go down to C, right to H, down to L. You can go down to A, right to E, down to L. Or you can go right to B, down to L. And what about intersection M? There are also four ways. You can go right to G, down to M. You can go right to D, down to I, right to M. You can go right to B, down to E, right to M. or you can go down to A, right to M. And there are 6 ways to intersection N. You can go right to D, down to N. You can go right to B, down to H, right to N. You can go down to C, right to N. You can go right to B, down to E, right to I, down to N. You can go down to A, right to E, down to H, right to N. Or you can go down to A, right to I, down to N. So now for intersections O through T, it's starting to get hard to keep track of all of these ways. Could there be some patterns or structures in Pascal's triangle to make it easier to find the number of ways to each intersection? Let's take a look at these numbers in a slightly different way. The numbers have been moved over from the intersection grid. Work with a partner to think about what number might belong in the spaces for O through T. Write down some patterns you notice and try to use the patterns to help you decide what numbers go in the blanks. Here's the next row. Which numbers did you fill in correctly? Which ones incorrectly? Remember that mistakes help to grow our brains. So let's think about both the correct and incorrect numbers to understand Pascal's triangle better. Which patterns helped us? Let's remove the letters now and just think about the patterns we see. We have already noticed a few patterns, but there are many hidden patterns in Pascal's triangle. Today you're going to work with a partner to hunt for more very interesting things to notice in Pascal's triangle. Happy discoveries!